Actually, while cross multiplying, we forgot to multiply 6 in there. So it is 7 minus r factorial is equal to 6 into 5 minus r factorial, which we got. Now what we are going to do in here, we'll try to write 7 minus r factorial in such a way so that we can get 5 minus r factorial in there. So what we are going to do is, we know that 9 factorial, we can write it as 9 into 9 minus 1 factorial into 9 minus 2 factorial. We can write like this, right? So here, so basically it is what? Oh, sorry, we made a mistake. 9 factorial, we can write it as 9 minus 1 into 9 minus 2 factorial. We can write like this, right? So we are getting what? 9 into 8 into 7 factorial. It's the same thing. So here 7 minus r factorial, we will write it as 7 minus r into 7 minus, look, if I am writing 7 minus r as 7 minus r plus 1 factorial, if I write like this, right? 7 minus r into 7 minus r plus 1 factorial. So what we are getting is 7 minus r, 7 minus r minus 1 factorial, that we are getting 6 minus r factorial, but I need 5 minus r factorial. So what we are going to do is, we will move back a little bit more. So 7 minus r, 7 minus r plus 1, 7 minus r plus 2 factorial. Now you see you are getting 5 minus r factorial. So 7 minus r, 7 minus r plus 1, 7 minus r plus 2 factorial is equal to 6 into 5 minus r factorial. Now let's see what you get. So we are getting 7 minus r, this one we are getting 6 minus r, and this one is what? 5 minus r factorial is equal to 6 into 5 minus r factorial. So this and this we can cut. So if you multiply this one, so what you get is 42 plus r square minus 6r minus 7r, that is minus 13r, is equal to 6. So I am getting r square minus 13r, and if you take 6 this side, you are getting out to be 36. This is what we are getting, right? Now we have to factorize this one. Quadratic equation, we have done this. So how to do this one? How to factorize this one? So 36, if you look at it carefully, so we get 3, 12, 3, 4. So you see, we can get in here, that is 3 3s are 9 and 4. So 9 and 4. So we can write here r square minus 9r minus 4r plus 36 is equal to 0. So here we are taking r common, we get r minus 9 minus 4 common, we are getting r minus 9 is equal to 0. So r minus 9 into r minus 4 is equal to 0. Therefore r is equal to 9 or r is equal to 4. That's my answer. So that's how we get this problem. Okay. Now let's move on to the next question, that is question number 8. Question number 8, what we have is, how many words with or without meaning can be formed using all the letters? So we are using all the letters of the word equation. Of the word equation, we are using all the letters, using each letter exactly once. So we have to use exactly once. So now first, when I look into this word equation, one thing is good, that there is no letter is repeated in here, right? So every letter, every single letter is different. So it means what? Every single object is different in here. So the permutation will be very, very easy. So the permutation will be what? We are taking, how many objects are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 objects are there, right? And we have to arrange them taking all at a time. So 8 objects are there. So n is equal to 8, and we are taking all at a time, means what? R is also equal to 8, right? So basically we have 8p8. There are 8p8 ways you will get the numbers by arranging equation. So you have to write here the number of words is equal to the permutation of the 8 letters of the word equation taken all at a time. Therefore, the required number is equal to the required number is equal to 8p8, and 8p8 is equal to how much? It is 8 factorial divided by 8 minus 8 factorial, that is 8 factorial divided by 0 factorial, and 0 factorial is 1. So you are getting the answer as 8 factorial. Now you have to write the value, and the value of this one will be 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Just multiply and write the answer. That will give you the answer of this question number 8. Now let's move on to question number 9. So question number 9, it says what? How many words with or without meaning can be made from the letters of the word Monday? So we have Monday in here, and assuming that no letter is repeated if 4 letters are used at a time. So my first question is that we are using 4 letters at a time. So how many letters are there? 1, 2, 3, 4, 5, 6. It's very easy if I'm using 4 letters at a time. So we have N as 6 and R as 4. So the answer will be NP4. 6P4. 6P4. So I hope I don't have to do question number 1. So please write it like the question number 8. And so basically I will just write the answer. 6P4 is the answer. So question number 2, it says that all the letters are taken at a time. Now again, it's very easy. If all the letters are used at a time, so it will be what? 6P6, just like the previous question. It will be 6P6. And the third one, all letters are used but first letter is a vowel. All letters are used but first letter is a vowel. Now this one is a very important question. All letters are used, the first letter is a vowel. So how many vowels are there? There are 2 vowels are there, right? Clear? Now if all letters are used, so it means what? If I do a box 1, 2, 3, 4, 5, 6. So obviously there will be 6 compartment because I am using all the letters, right? But they have given you the condition. A condition is what? The first letter is a vowel. So vowel, how many vowels are there? There are 2 vowels are there, O and A. And how many ways we can fill this compartment 1? We can fill this compartment 1 in 2P1 ways. There are 2 vowels are there, and we will select one at a time and to fill this first position. Then how many remaining positions are there? There are 5 remaining positions are there, right? And how many remaining letters are there? There are 5 remaining letters are there. So it will be 5P5. So 5P5 ways we can fill the remaining compartments. Then what is the total numbers of words we will get? So the total numbers by by multiplication principle, we can write it is 2P1 into 5P5. That will be my answer. Okay, so let me write this one in here. So all letters are used but first letter is a vowel. So let's write this one. The first letter is a vowel can be done in 2P1 ways. In 2P1 ways we make the first letter to be vowel. Then what we have is that now and the remaining letters can be filled in 5P5 ways. Hence by multiplication principle, by multiplication principle, the number of ways, the number of words is equal to 2p1 into 5p5. So the answer will be, it is 2 factorial divided by 2 minus 1 factorial into 5 factorial divided by 5 minus 5 factorial. So that is coming out to be 2 factorial into 5 factorial, because 5 minus 5 is 0 factorial and 0 factorial is 1. So then you have to multiply and write the answer. So this is how we do question number 9. Okay, now I am leaving it, I am not writing the answers. You please do it just like we have done in question number 8. You have to do it. Now let's do question number 10. So question number 10 says Mississippi. So in how many of the distinct permutation of letters in Mississippi do the 4 I's not come together? Now this one is important. So we have a word that is Mississippi. So this is the word which we have, Mississippi. In how many of the distinct permutation of letters in Mississippi do the 4 I's not come together? Now this is very interesting. Now look at here. First, when you look at this problem, so here my problem is that the 4 letters, the 4I does not come together. 4I does not come together. So this is my question, that they never come together. Now we will try to approach this question in a different way. We will try to find the number of ways 4I comes together. 4I comes together, right? And then what I will do is, first thing we will find the total number of ways we can arrange them, total number of ways. Now from that total number of ways we can arrange, if I subtract the number of ways in which 4I comes together, then we can easily get the answer that the 4I does not comes together. So basically we have changed the problem, the approach of the problem into a different way. So first we will find the total number of ways we can arrange all the letters of Mississippi. Then from that we will subtract the number of ways in which 4I are coming together. And at the end that will give us 4I does not come together. So first thing, let us find the first question. So the total number of ways we can arrange Mississippi. So let's write down the number of ways the letters of the word Mississippi can be arranged. Now here you see there are certain letters, they are repeated. So how will we do it? First thing, let us count how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters are there. So can be arranged by 11 factorial divided by. Now how many elements are alike? I is alike. And how many I are there? 4 I are there. So I will write 4 factorial. How many S are there? 4 factorial. How many P are there? 2 factorial. So this is the total number of ways we can arrange Mississippi without following this condition for now. Now, how many ways in which 4I comes together? Now this is the important bit. Now suppose this 4I comes together. Now think of that 4I as a single thing. Think of this 4I as a single alphabet, okay, single letter. Now what we have of Mississippi? So we have M, S, S, M, S, S, P, P, I. Okay, clear? So I am thinking this I basically contains all the 4 I's. Clear? So how many letters now we have? How many letters we have? 1, 2, 3, 4, 5, 6. So wait a second. We have 2p, we have 4s, sorry. We have 4s in here. We made a mistake. We have 4s in here. So 4s in here and 2p and 1i. 1i, why? Because I'm combining all of them together. I'm keeping them all of them together, right? So basically, if now all I have to do is find the number of ways we can arrange this one. Now if I find the number of ways we can arrange this one, now this will signify that all the i's are together, because I'm thinking of all I as a single entity I, right? So now what we have is, how many letters we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 factorial divided by how many equal entity are there? 4. How many equal entity are there? 2 factorial. So now we don't have to write divide by 4 factorial, because there is only one I in there. There is only one I in there, because I only can see only one I. So this is the number of ways we can arrange, we can have the arrangement of Mississippi when all I's are together. So let's write down, let all the 4 I be a single letter then the number of ways we can have all the i's together is, that is 8 factorial divided by 4 factorial into 2 factorial. So this is the number of ways we can have all the i's together. So after this we can easily get the answer. Therefore the number of ways 4 i's does not come together is equal to 11 factorial divided by 4 factorial, 4 factorial, 2 factorial minus 8 factorial, 4 factorial, 2 factorial. That will give you the answer. Now if you do the LCM, you will get 4 factorial, 4 factorial, 2 factorial. So 11 factorial minus 8 factorial, 4 factorial. Now if you solve this one, then you can easily get the answer. Okay, clear? So that's how we solve this question. Now you just have to multiply and find out the value. So this is how we do question number 10. Now the last question, that is question number 11. Question number 11 is the last question. It's very, very important. Now question number 11 is what? In how many ways can the letters of the word permutation can be arranged? So here we have permutation. Permutations be arranged if words start with P and end with S. Now this is very, very important. Words, now how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there basically 12 letters are there. Now if I think of a box which has 12 compartments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So we have 12 compartments, right? So basically we have to find the number of ways to arrange these letters such that it starts with P and ends with S. Now you see, so how will we solve this question? So what I do is, I will put that P in here and put S in here. So I don't have to do anything because I have already put P in there and S in there. So there is no number of ways we can arrange them. There is no need to do anything with that because I just picked up P and put P in that first compartment and my job is done. Then I picked up S, then I put S in there, then my job is done. And how many ways we can put in there? It's one way and one way. So it's no problem. Clear? So they are basically 1, 2 events, right? Now what are the remaining What about the remaining compartments? Now the question comes. The question number 11, permutation. What are the remaining elements are there? E, R, M, U, T, A, T, I, O, N. So I will see how many repeated alphabets are there. So if I look at carefully, I have two T's. I have only two T. The others are not repeated at all, right? So how many spaces do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 spaces, right? And there are 10 alphabets to be filled. So how many ways we can do it? So it will be 10 factorial and 2 factorial. 2 similar are there. So 2 factorial. So there are 10 factorial divided by 2 factorial. And these are 1, 1. Actually, we don't need to write this one. Multiplication principle. So it will be 10 factorial divided by 2 factorial. That will be my answer. Because P and S, they have already been kept in there. So the arrangement is basically other compartments neglecting the P, the first one and the last one. Clear? So the arrangement will come in the middle portion. So the answer will be here. So words start with P and ends with S. So here what we are going to do is the number of ways, the number of words starts with P and end with S will be permutation of the 10 remaining letters taken, the permutation of 10 remaining letters taken 10 at a time. Taken 10 at a time, where the letter T, where there are 2 T. Okay, so hence, so what we have in here, therefore the required numbers are 10 factorial divided by 2 factorial. So that will be, that gives us, you can write this one 2 factorial, so we can cut this one into 10 into 9 factorial divided by 2. So you can write this one as 5 into 9 factorial. Then you can multiply and you can write the answer. Okay, so that is my question number 1, where P and S are fixed. Then what we have, question number 2 says that all the vowels are together. All the vowels are together. Now how many vowels are in there? So let us see, there is E in there, there is A in there, there is U in there, there is I in there, O is there. So all the vowels are present in here. A, E, I, O, U, right? So we have to keep all the vowels together. Now again the same thing. How can we keep all the vowels together? By thinking of them as one. By thinking all the vowels as one entity, I will keep them as together, right? So how many, now if I take all the vowels as one, let us take this one as V, as one element. So how many numbers we have then? So we have P is in there, R is in there, M is in there, permutation, 2 T's are in there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 S in there, and another one. What is that? 1 R we have taken, 1 N, yeah. So these are the letters are there, and we are taking this E, A, U, I, O, A, E, I, O, U as the vowels V. So how many total letters we have? The total letters is 1, 2, 3, 4, 5, 6, 7, 8. After taking all the vowels together, we have total letters as 8. So how many ways we can arrange these 8 letters? So we can arrange them in 8 factorial divided by, there are 2 T's are there, divided by 2 factorial, right? So this is the number of ways we can have when all the vowels are together, but this is not it. That's not the correct answer. The correct answer is, look at here. You see all the vowels are different in here, right? Now since all the vowels are different in here, obviously if I have this one as O, A, E, I, O, oh sorry, O, A, E, I, U, again we have all the vowels together, but you see this one and this one is different, right? So basically among this box in here, this box in which we have all the vowels together, we can arrange them also. So how many ways we can arrange E, A, U, I, O? How many ways we can arrange the vowels? There are 5 vowels are there, and we can arrange the vowels in 5 factorial ways. In 5 factorial ways we can arrange the 5 vowels. So basically this will be my answer. So that is 8 factorial divided by 2 factorial into 5 factorial. Okay. So we'll do what? So let us take all the vowels. Let me erase this portion. So let us take all the vowels as one letter. Hence, then we can arrange the 8 letters. 8 letters means what? I am taking the vowels as one and the remaining 7 letters what we have in there. So hence we can arrange the 8 letters in 8 factorial divided by 2 factorial ways, right? We can arrange the 8 letters, but in here the vowels can be arranged in 5 factorial ways. In 5 factorial ways, or you can think of it as 5p5. If you have 5 factorial is a problem, think of it as 5p5. There are 5 vowels are there and we have to take 5 at a time and you have to arrange them. And 5p5 is what? 5 factorial divided by 5 minus 5 factorial. So that is 5 factorial by 0 factorial. That is also 5 factorial. So the vowels can be arranged in 5 factorial ways. Hence, by the multiplication principle, the required number of ways, that is equal to what? 8 factorial by 2 factorial into 5 factorial. Then you multiply and get the answer.